amplify resistors but current doesn't?
In a series, like right in this part you mean?
Yeah.
In a series, the voltage will be split, but the current won't.
Okay.
In a parallel sense, the voltage does not get split and the current does.
Oh, okay.
So that's a lot of people are still mixing those two words up. But when we go over here, we're going to find the voltage gets split up because it's in series, but the current's all equal.
I thought voltage always stayed the same.
In parallel, these two parallel branches, or two different branches, will have the same voltage drop across them. In series, these three have to add up to the total voltage when we get done. And for me, at least, I don't know if it'll help you or anybody else. I like to think about the loop. I know in this loop, I have to use up all of my voltage, and then I can start thinking about how that voltage gets used up. In that loop. There's two things. I have to split it up. If there's only one thing in the loop, it's very simple.
Wait, why did you? Okay, so why did you divide 7.5 by 10?
Now I'm trying to solve for the current. This is using that V equals IR equation.
Yeah. Oh, okay. I was thinking it was V equals I. Hold on. Okay.
Verb.
Yeah.
Okay. Now here's a good question for you. What would, I wouldn't bet half your are getting it wrong. What would the current out of the battery be in this circuit right now? I'm going to give you two choices. The answer is, well, I don't know if there's anything else. The answer would can either be 3 or it could be 2.25. I'll give you a third choice just to really try and throw you off. Or it could be 0.75.
And what are we doing?
Everything right there.
In the first.
That's so much.
The current out of the battery.
In the
How much what?
The current right here is 1.5 amps. The current through this and this is 0.75 amps.
Oh.
I want to know the current in this part of the wire where both loops travel. So who thinks the current out of the battery is going to be 3 amperes? Who thinks it'll be 2.25 amperes?
Why?
Who thinks it'll be 0.75 amperes? Okay, the answer is the middle one. Now this is why you guys are guessing 3. We don't, in this branch, we don't add the 0.75 twice.
0.75.
Because we just say the current in this branch is 0.75. We don't add that up. There's not 0.75 plus 0.75 coulombs per second over there. There's only 0.75 coulombs per second going that way.
So
Kirchoff.
resistors in parallel don't split current.
Say that again?
Resistors like in a parallel thing, like don't, you know how like oh.
I mean series. Series, same current.
Yeah, okay.
So we just add up the currents. The currents in the branches get added together. Not each. Like if there were 4 electrons over, or 4 resistors over here, each had, or 5. Each had a 0.75 amp current. You wouldn't add up all 5 of those currents and then find out what the total current is. You just do the whole current of the branches added together in this equation here. That's why I asked that, because I thought a lot of you would still think it was 3.
So where do you get 2.5 from?
The 1.5 amps plus the 0.75 amps. Okay? Questions about that?
So because the current stays the same in the last, like straight down?
Right, from here to here, the current's 0.75 ampere. The 0.75 ampere or current coulombs per second traveling in that branch.
Hello.
Wait. How come? Another question. Current through R3. Yeah. We had 0.75.
Let's say stuff.
No, so it's related.
Oh.
That's the correct answer.
Polychloro.
Are you ready now? Good, great. So, question 2. We need to now do the same thing in series. This is a 15-volt battery again. These are each 10 ohm resistors.
I have a question. I don't know the difference between a series and parallel.
Series is when there's one path only, like this one. Parallel is when there's choices. But when you might say this is a series branch in a parallel circuit.
Okay.
You see what I'm saying?
Yeah.
A series, one choice, or no choices, one path only, parallel, multiple paths.
The sub was like telling me
Oh, yeah,
about like the
explained it
batteries
wrong,
and
yeah.
stuff.
I know.
Yeah.
It was really, can you explain that again?
Series, one path only, parallel, multiple paths.
Yes, about how if it's in a series, like the batteries are next to each other, or something, like
Yeah.
buses are together, or
Series
Hey, focus. Hi. Are we good with that? And then you might also say, if you wanted to, that this was a series branch in a parallel circuit. Because there's two resistors in parallel right there in a bigger circuit as well. The word series comes from the word serial, like a serial number is a sequential list of numbers. Serial killer, same idea, I guess. Okay, 15 volts. I have to make a loop. Only one loop in that. That's another thing I guess that would define a series circuit, and there's only one loop in the whole thing. You agree, Dominic?
Yes.
I'm glad you agree. So, how many volts does a positive charge leaving that battery have to use up? 15 volts. And since there's 3 resistors, and they're all the same resistance, they would each take up 5 of those volts. If they were different resistances, it wouldn't be that simple. You have to do a little more work for that answer, but that's the basic answer you do there. Yes, ma'am?
I have a question. If it was current, would it be the battery's output then?
Well, in a series circuit, the current is the same in all places.
Okay, that's why I got that.
So the current would be
Current would be then the 5 volts over 10 ohms, which would be 0.5 amperes for all the points in that circuit.
Okay.
I guess
And again, the basic reason is a lot of people would think that it's going to be a decreasing current as you go through the circuit, and that would not, it's not really possible because if you're at this point counting, you see half a coulomb every second go past, and down here you only see a third of a coulomb per second going past. You've again lost 0.2 coulombs per second somewhere, and that's just not possible. You can't lose charges, like charges of physical little balls that are inside this wire. They don't just go away, right? Yes?
yeah, but if they were different resistors, then the current wouldn't be the same over all of them, or what?
You'd have to do like 15 plus the total resistance. I mean, really what we're doing here, again, we're doing our Kirchoff loop rule. We're doing V minus IR minus IR minus IR equals 0 like we did last week. But since they're all the same resistance, I can cheat a little bit. Good? Great. Other questions on that one? That one's a little bit easier.
Now we're at number 3.
We're number 4 first, actually.